Hello everyone, myself Kashyap, and I am applying for the position of coordinator in the programming club of IITM. And as a part of section 2's question 4 of the application, I am asked to solve a Codeforces question with a rating 200 greater than my current rating. So my current rating is 1140 and I have chosen this question which is rated 1900. I have solved this question a month or two ago and I like this question's logic a lot. Now what this question has to offer is we have an array which is initially empty and then we can perform two types of operations on this array. The first type is appending an element to the end of the array, and the second type is to make x copies of this array and add it to the end of the array, that is basically multiplying the array x plus 1 times. Now what we cannot do over here is do all of these operations manually. Sure, we can append the element x to the end of the array manually, that is fine, but this multiplication operation we cannot do manually as x can be quite large, and doing this manually over and over again till the given size of 10 power 18 exceeds the memory limit as well as the time limit. So we have to come up with a better solution for this. Luckily I have the good solution. Now let me pull up my notes for this to explain it in a better way. Now let's say we have an operation of the first type, then we are maintaining a map to maintain the elements which are appended. Now we are using a map instead of a vector or an array because we are inserting an element at like random instances and we are not applying that where there is multiplication operation going on. So most of the places are left blank. So to save on memory we are using maps. And now also we have the second type of operation, b is equal to 2, which requires us to multiply the array. Now we cannot do this as I talked about earlier, so we are doing a sort of operations on the size, and for this let's maintain an array, and in this case a vector called SBM. I am calling this SBM because we are using this to store the size before multiplication, that is SBM. And then when this is done, let me explain why we are doing this. Now let's consider a multiplication operation with the initial size of the array being n. Now for reference, let's look at an element with index n in the n element array. Now when we are doing this multiplication x times over, we can notice that this same element in the second multiplication at rth position has a difference of index with the first element as n, because the size of the array is n, and the same thing for the next part. So what we can see here is the rth element is equal to the n plus rth element and is equal to the 2n plus rth element, and so on till the xn plus rth element. So this forms an arithmetic progression with the first element being r and common difference of n. So what we can say is we don't have to store all of this. Xn plus rth element is equivalent to the r, so what we can do is we can just take the remainder of the element with n. So for example, we have a 3n plus rth element that we have to find. We can take the remainder with n, so we have the rth element as the resultant remainder, and so we can just store this 1 to n instead of storing this till 1 to nx plus 1. So this simplifies our operation. Now this is for one multiplication operation. Now we can take the remainder and check if it exists in the map. If it does, we output the element. If it does not exist in the map, then that means that that element is involved in the previous multiplication operation, and we again take the remainder with the previous size, and so on till we finally find it in the map. The code for this is over here. I have coded this in C++, and then let's see a few hash defines before we go on. Unsigned long int is defined as LLT, as this size can go till 2 into 10 power 18. That's why I have taken the unsigned. Now vector for long int is VLLT, pushback is PB, and then for loop is simplified as L. Now /n is endl. Now let's see the operations that we are conducting initially on the array. Now for the n operations, we are maintaining a variable s starting from 0 as the size of the array, instantaneous size of the main array. Now let's take inputs b and x. If b is 1, then it is an operation of the first type where we have to append an element. So we are incrementing size by 1, because when we add an element, the size increases by 1, and at that size the element is x, so the map of s is corresponds to x, and then if the b is equal to 2, that is the multiplication operation, what we are doing is we are pushing s to the SBM array, that is before the multiplication, and then we are multiplying s by x plus 1 after that. Now we have a few constraints here that we have to look at. Now they said the size of the array cannot exceed to 10 power 18, so any operation after that is redundant. Now we know that any number of multiplications doesn't matter because we are taking the remainder anyway. So let's take the minimum multiplication case of 2. So 10 power 18 with the minimum multiplication case will give 2 into 10 power 18, and that is all we have to store the values still. After that is all unnecessary values which they won't give in the input and we don't need to store them. So if s is equal to 2 into 10 power 18, then it just continues by ignoring the unnecessary case. And if s is like s times x plus 1, that is the resultant size is greater than 2 into 10 power 18, then s is made 2 into 10 power 18 by ignoring the further elements, and if not, then we are multiplying s times x plus 1 as we have seen. Now this is for the operations that we are conducting on the array. Now coming to the queries, for each query we are given an input of k, that we have to find this is the index of the array, and we have to find the element corresponding to this index. Now we are passing a few operations on this k till we find an element that corresponds to this in the map. Now we can take the remainders, as we have seen, from the end of the SBM array, which takes the remainder n times if n is the size of the SBM, or we can do binary search on this SBM array, as we know that SBM is like always increasing. So we can do binary search to find the index which corresponds to the maximum element in such that it is less than k, and starts the remainder from that point, because after that it's the unnecessary remainders that we are taking. Anyway, for this, the general case, we are taking the total size of the SBM vector for doing the remainder. Now we are running a while true loop in which we are initially checking if the kth element corresponds to a value in the map which is non-zero, that is a value exists in the map. If it does exist, then we are just having to just print that value, that is the required output, and then break the loop because we have found the element. If not, then it is involved in the multiplication, in which case we are taking the remainder of k with the value at SBM. But we have a problem with this, as we are taking the remainder. Let's say k is at nth position when the SBM value is n. In that case, then k will be 0, which does not exist in the 1 to n index system. So in that case, if k is 0, that is if it is a multiple of SBM, we equate k is equal to SBM. So with this, we are doing x minus minus to go to the previous value of SBM with which we can take remainder. And this loop goes on and on until we find a value of k which corresponds to a value in the map which is non-zero, which is the element we need, that is. And we can always say that this loop ends because there should always be an element appended which is not involved in the multiplication, always. So there is always a breakpoint in this loop. So this loop does not run for infinite time for any set of input. It always breaks when it finds an element in the map, and after which we can just see out endl and be done with the question. And this is the main function that I am running for t times t number of test cases, and this is how we are able to solve this question, let me just open this up and show how my submissions are. Initially they were going wrong, true, but I managed to solve this, in which these two submissions are using binary search and they ran in about 2.5 seconds comfortably enough. And then these three ran with x is equal to the total size of SPM array, which ran in about 3 seconds average, and the time limit is 4 seconds, remember. Now talking about the time complexity of this question, now let's consider this part of the code where we are running the n operations. For each operations we are changing the s, either adding 1 or multiplying x plus 1, that is one operation, and then either we are adding this to the map or we are adding the value to the SBM, which is just adding a value to the array. So it is O1 for each operation. So as there are n operations, this whole part of the code runs in On time complexity. Now the next part, that is the query part, is where the time complexity rises. Now let's take each query. For the each query, let's take x is equal to n, and we are running this loop n times in the worst case till we find a value which corresponds in the map. If k value is the first element, then it has to run n times before it breaks. So the worst case, it runs n times. So the time complexity for each query is O of n. As there are q queries, we can say that the total time complexity of this part of the code is ONQ. Suppose we are running binary search on this, that is using this part, then the time complexity for this part is log n, and then for this part is n log n, the total part. So in total, this whole part will be nq log n, which appears to be more than taking SBM total size, but provided that we don't have worst case scenario inputs, that might be more efficient, which is what happened in the given test cases of Codeforces. But we don't necessarily need that, as we are not assured if it is more efficient or not. I have taken the total size. Now talking about the total time complexity of this, including this and this, it is ONQ, which may seem like it is not efficient, as both n and q go till 10 power 5. So it is like total time complexity of 10 power 10. But we are given, this is considered, and Codeforces has given us a time complexity of 4 seconds, which is comfortable enough to run this code as I have shown, and it runs in about 3 seconds. So that is it for this question. Thank you very much for listening to this whole video, and if you have, please take this as a consideration in the code application. Thank you.